What's up, geeks, and welcome to the channel. Suppose you are a professional robber planning to rob houses along a street. Now, each house has a certain amount of money stashed inside it, and the only constraint stopping you from robbing all of them is that adjacent houses have security systems connected, and it will automatically contact the police if adjacent houses were broken into on the same night. So, given an integer array representing the amount of money inside each house, you should return the maximum amount of money you can rob tonight without alerting the police. This problem is known as the house robber problem and is very popular among interviewers who pick dynamic programming exercises. So, how do we tackle this problem? Well, the main idea is realizing that each house, each integer in the array, has two options to choose from and only two, either be robbed or not. So, we can either pick an integer from the given array and add it to the total sum to return, or we simply don't pick it. Given this, the first solution that you may think about is the recursive one. You see, recursion is identified by solving a subproblem repeatedly until we figure out the larger problem at hand. And here, the subproblem is each house taken individually, while the larger problem is the maximum amount we'll be able to steal from all the houses combined. So, if we decide to steal the first house, then we can't steal the second one, but we can steal the third one, and vice versa. Which means that our decision will be based on the simple equation you see. If the amount of money stashed in houses 0 and 2 is smaller than the one stashed in the house number 1, then we should steal house number 1, right? So, if the array we had consisted of n houses where n equals 3, then the maximum amount we can steal is the maximum between the money stashed at n plus the money stashed at n minus 2 and the money stashed at n minus 1. That is the solution to the subproblem. Let's scale it up and solve the larger problem at hand, and suppose the array now has 6 houses. You see, the equation we just wrote now applies to the last 3 elements of this array because n equals length minus 1, right? But these two numbers right there do not represent our only choice anymore, and hence need to be maximized. This is done with the help of the same formula by considering that their actual position is the last one, which must be maximized, just like length minus 1. So if we had n houses regardless of what n is, then the maximum amount of money we can steal after wandering around all n houses will be the maximum between the money stashed at house number n plus the maximum amount of money we can steal after wandering around n minus 2 houses, and the maximum amount of money we can steal after wandering around n minus 1 houses. That's it. That is the recursive solution to this problem. All we need to do now is add the breaking conditions, which should be straightforward, throw in the initial recursive call, and you did it. Now, previously on several occasions we discussed the drawbacks of recursion, and the solution to this is making use of dynamic programming. You see, recursion, just like memoization, is a top-down approach, meaning if we were to represent this logic as a series of calls, the first call we made would be the solution we are looking for. It starts looking for answers from the top of the tree. However, tabulation, which we also previously explained, is a bottom-up approach. It starts from the first and basic scenarios of our subproblems and builds up to the solution we want. So, how do we derive the tabulated solution from the recursive one? Well, to do that, we'll need to create an array, and this array should store at first the basic scenarios, which will be very similar to the breaking conditions we defined in our recursive approach. Hence, the first index will store the first integer, and the second one will store the maximum between the first and the second. Now that our basic conditions are set, we can use the same exact logic we made use of in the recursive approach. So, all we must do is loop over that array starting at the third position, and set the number at this position to be the maximum between the current money stashed plus the amount at i-2 and the amount at i-1. Finally, the answer we seek will be found at the last position of this array, representing the fact that we wandered around all the houses. Okay, this solution is way better than the recursive one as it is linear in time, but what if I tell you that there is still a way to optimize the space we are using? You see, in the code we wrote, we are making use of an additional O of n space because of that array. So, can we get rid of it? Well, if you take a closer look, you will notice that while traversing this array, and at any point in time, we are making use of 3 values only. The current house or index we are at, and the 2 indices preceding it. All the other values that come before our current index minus 2 are obsolete, we don't need them anymore, hence there is no need to store them. So what we can do is replace that entire array with just 3 variables. 2 of them will keep track of the 2 previous maximums we found, and 1 will be used to store the current maximum we are retrieving. As soon as we shift to a new house, these values will also be shifted to reflect that new iteration. And that is the complete and optimal solution to the famous house robber problem. Okay, after you solve this, the interviewer might choose to scale things up and modify the question a little bit. What they might add is that the houses are arranged in a circle. So how does this impact us? Well, in the previous question and in our previous solution, we were allowed to rob both the first and the last house. Now we can't because they are considered adjacent. So we will need to alter our current solution to take this new criterion into consideration. How do we do that? Well, remember the basic idea we started this video with, and it's that each house is faced with two choices and only two, either be robbed or not. Meaning that this new instruction basically boils down to deciding if we want to rob the first house or the last one, as we can't do both. So if we decide to rob the first house, let's say, it means that the answer to our problem can be retrieved with the help of the previous solution by applying the same exact logic on the array from index 0 to index n-2, we just disregarded the last house. And if we decide to rob the last house, it means that the answer to our problem can be retrieved in a similar way by applying the same logic on the array starting from index 1 or the second house all the way till the last one. We just disregarded the first house and decided potentially to steal the last one. Then the maximum between these two answers or maximums will be the actual answer we are looking for and should return. That's it. The links to the LeetCode exercises we solved today can be found in the description below. Let me know your thoughts and suggestions for upcoming videos in the comments section. And that's it for today. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.